Here's example 17 with establishing trig identities. So again, if you'd like a copy of this packet we've been using for all these videos, if you want to follow along with that, check the video description here. There's a link. You can click that link and open up the packet, print it out, and follow along if you'd like. So tangent of alpha plus cosine of alpha divided by 1 plus sine of alpha equals secant of alpha. Okay, so that's the identity that we want to establish. So if we go back to our general process from an earlier video on the first page here, always start on one side, try to make it look like the other side. Usually start with the more complicated side. So the left side is definitely more complicated because the right side is just one function. The left side is one function plus a quotient here, and there's more addition here, so a lot of stuff going on the left. So let's start with the left, manipulate only that side, and make it look like the right side. Okay? So tangent of alpha plus cosine of alpha divided by 1 plus sine of alpha. Okay, so what can we do? So nothing really jumps out at us, but we've actually talked about this in an earlier video. When you have something like this, okay, with where you're not really sure where to go, and what we have here is something over 1 plus sine of alpha. Let's maybe take that, so tangent of alpha stays tangent of alpha, and then cosine of alpha over 1 plus sine of alpha. Let's try multiplying that by 1 minus sine of alpha over 1 minus sine of alpha. Okay, will that always work? No, it may not always work. There may be cases where that doesn't really get us anywhere, but there's no harm in that. We can try something. If it doesn't work, just try something else. Let's zoom in a little bit. Okay, so, and remember, it's sort of like rationalizing the denominator. It's not exactly rationalizing because we're not taking an expression and making it rational, but it is sort of, it's like the same concept and spirit, really. So if you have something like 2 over 1 plus root 3, like we explained in an earlier example, and if you want to rationalize the denominator, then you multiply by 1 minus root 3 over 1 minus root 3. Okay, so it's the exact same concept. We have blah, blah, blah on top, and then 1 plus something, so we're going to multiply by 1 minus that same something over 1 minus that same something, right? So 1 plus root 3 multiplied by 1 minus root 3 over 1 minus root 3 to rationalize the denominator. Okay, but here we're not really rationalizing anything. Okay, it's just the same concept, but it's not really called the same thing because we're not taking an irrational expression like root 3 plus 1. We're not taking that irrational expression and making it rational. Okay, we're just taking this function here and multiplying it by this expression here. Okay, take this expression, multiply by this expression, see if that gets us anywhere. Okay, that's all we're doing. Okay, so let's continue with that. But we've done something similar to that in a previous example, but we just want to explain it again in case you missed that example. Anyway, so now on the bottom, let's FOIL, and on the top, we'll just leave it expanded, or sorry, leave it factored. Don't expand, don't distribute, leave it factored. So on the top, we still have cosine alpha times 1 minus sine of alpha. Now on the bottom, we could use the fact that this is a plus b times a minus b, or if you're not comfortable with that, you can just FOIL, and you'll say, okay, first is 1 outer minus sine of alpha, inner plus sine of alpha, last minus sine squared of alpha. Okay, and then let's simplify that. So this is a tangent of alpha. Okay, these are alphas here. Alpha plus cosine of alpha times 1 minus sine of alpha, parentheses there. So we can be careful with these parentheses because it's cosine times this entire thing here. Okay, so we got to have these parentheses here. Okay, so be careful about that. And then what happens on the bottom? Minus sine of alpha plus sine of alpha, they cancel. That's great. So now we're left with 1 minus sine squared of alpha. Okay. All right, now where do we go from here? So from here you might think, okay, well, can I factor this? Yeah, you can factor it, but you'll actually just undo everything you just did. If you factor it, you'll just be back to where you started. That's not really what we want to do. So instead of factoring this on the bottom, because remember it's 1 minus sine squared of alpha, that's a difference of squares, because 1 is the same thing as 1 squared. So it's 1 squared minus sine squared of alpha, so that's the difference of squares, so you can factor that. But we don't want to do that here, because that's just going to undo what we just did. Okay, so we multiply these guys together. So if we factor this, we're just going to undo what we just did here. But what we can do is something else that we have done before several times now, is use the Pythagorean identity. Sine squared of theta plus cosine squared of theta is 1. Okay, So we have that identity we could use here. Now, it's not exactly useful in that exact form, but we can take a previously established identity, manipulate it however we want, as long as it's a legal manipulation. Okay, we can manipulate it however we want legally to be more useful to us. Okay. Now, remember, when we establish an identity like this, we're establishing this identity here. So we have to start on one side and only work on that side. Okay, so we cannot mix the sides together. We can't add something to both sides, subtract from both sides. We cannot do that here because we're establishing this identity. Okay, so when you establish an identity, you only have to work on, or you can only work on one side. But if you want to use a previously established identity, a well-known one like this, you can manipulate it however you want. So as long as it's legal. So let's subtract sine squared from both sides. So then we'll get cosine squared of theta equals 1 minus sine squared of theta. Okay, but we have alphas instead of theta, but that changes absolutely nothing. Okay, so let's go to the board real quick. So we know that sine squared of alpha plus cosine squared of alpha equals 1. So if we subtract sine squared from both sides, then what we're going to end up with is cosine squared of alpha equals 1 minus sine squared of alpha, right? So whether it's alpha or theta or t or u or v or w or x or y or z, whatever, does not matter at all. So the point is cosine squared of alpha is 1 minus sine squared of alpha. We've used this fact or facts like it in several examples before already. So we see that it is something pretty common in trig identities. So definitely want to keep that in mind. So anyway, this is now tangent of alpha plus cosine of alpha times 1 minus sine of alpha, all divided by 1 minus sine squared is cosine squared, is what we just saw. Okay, so cosine squared of alpha. So now we can cancel. So cosine of alpha cancels with one of these down here. So cosine squared of alpha, that's cosine of alpha times cosine of alpha. One of them cancels with the one on top. And then what we're left with is, let's zoom out a little more. So let's come up, first let's erase this. And we'll come up here. Okay, so then this equals tangent of alpha plus 1 minus sine of alpha over cosine of alpha. Okay, what can we do here? Well, now what's good about this that we didn't have before, so before we had something like this, and the denominator 1 plus sine of alpha, that's not really good, we can't split anything up. But what's nice about this is in our denominator we only have one term, so now we can split it up into two, we can split up this quotient into two quotients. And do we know right away that that's a good thing to do, or that's going to help us? No, we don't know right away that it'll help us, but there's not much else we could do, so let's just try it. Okay. Now actually another thing we could do is tangent of alpha, we can rewrite that as sine of alpha over cosine of alpha and get a common denominator. Okay, we can actually do that. There's no reason we can't. That's actually not a bad idea, but since we already started this other way here, so tangent of alpha, or we already started talking about it anyway. So tangent of alpha plus 1 over cosine of alpha minus sine of alpha over cosine of alpha. Okay. So now we have that. Let's zoom in a little more now. Okay, so all we did is we just took this quotient here and split it up into two. Okay, so 1 minus sine of alpha all divided by cosine of alpha. We can split it up into two quotients. So 1 over cosine of alpha minus, okay, minus sign here, sine of alpha over cosine of alpha. That's tangent of alpha plus 1 over cosine of alpha, that is secant. Okay, that is secant. So we're going to convert that because we eventually want a secant of alpha in the end. So here is our secant, so let's write that. And then sine of alpha over cosine of alpha, that is tangent of alpha. And notice tangent of alpha, blah, 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 minus tangent of alpha, so they cancel. That's great. And we're just left with secant of alpha, which is exactly what we wanted. Check mark, we're good to go. And that's it for example 17. So let's just recap this real quick. We have this expression here. We started with the left because it's more complicated than the right side, so we start with the left side. And we say, okay, nothing really jumps out at us, but when we have something like blah, blah, blah on top, and then just the one thing on top, a cosine of alpha on top, just the one thing, and on the bottom, 1 plus sine of alpha, let's try this technique here that we actually have used before in an earlier example, and it's more generally applicable in math also. It's the same thing as rationalizing the denominator. Let's try that same concept here. Okay, but again, this is not rationalizing what we're doing here. Okay, or what we're doing here is not called rationalizing the denominator. That's not the same thing. It's the same mathematical concept, but it's not really what it's called because we're not rationalizing anything here. Okay. Anyway, just some little details there. But anyway, we have this here multiplied by 1 minus sine of alpha over 1 minus sine of alpha. FOIL on the bottom, and you end up with 1 minus sine squared. Leave the top factored. Use the Pythagorean identity. 1 minus sine squared of alpha is cosine squared of alpha. Cancel the cosines. And then from here, there were a couple different ways to go. So the way we went was we split this up into two fractions and simplified from there. Now we could have also said, okay, tangent of alpha is sine of alpha over cosine of alpha, okay? And then we're doing plus 1 minus sine of alpha over cosine of alpha, okay? So we can actually, so since tangent is sine over cosine, then we already have a common denominator, so we can put them together all into one. So sine of alpha plus 1 minus sine of alpha, okay? All over cosine of alpha. So then sine of alpha, blah, 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 minus sine of alpha, they cancel, and we're just left with 1 over cosine of alpha, which is secant. Okay, that is secant of alpha. So I just want to point that out there because that is another way to go from here. Okay, so it's just another example where we have a problem where we established a trig identity, and there are multiple ways to do it. Okay, so and you know it starts the same way, but then here's where we can go in two separate directions. So just another thing to point out there, with trig identity problems, when you establish trig identities, there may be more than one way to go, and that's good. Anyway, that's it for example 17. Example 18 coming up next.